Hello, Assalamualaikum. My name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain about the slab 3 for part 3, control system PID controller. So my part is I'm going to do for 3.1 and 3.2. So I'm going to start for 3.1. 3.1 require us to tabulate the desired output. So as you can see, the step time is 2. Initial value is 2000 and the desired RPM is 6000. So this is the block parameters speed reference that I take from block diagram here. As you can see, okay, the speed reference is still the same. The step time is 2. The initial value is 2000 and the final value is 6000. Okay. So I'm going to continue for 3.2. I'm going to continue for 3.2. Okay, 3.2. So same. This he say P controller the scope result pin screen of each tuning steps. Okay. For the block diagram is still the same from part 2. We use so my part is P controller. So it's just different because we need to tuning for each controller. We need to tuning for this part 3. That is the difference. Okay. So okay, I will show you. I open the block parameters for PID controller. I set the controller P. Okay. I tune. Okay, wait for the tuning. Wait for the tuning. Okay. Wait for it appears. Alright. Okay. So this is the PID tuner for P controller. As you can see, we have the tune response. Tune response here. Okay, we don't have the block response because this controller require biasing or manual when used alone. This is because it never reaches the steady state condition. It provides stable operation but always maintain the steady state error. Okay, this is the tuner for this P controller. You can see this amplitude per time per second. Tune response here, and then I show you the show parameters. So in order to get the response, we need to tune. Okay, we need to tune this P controller for this part 3. So P is negative 0.28123. ID and N is not available. So the performance and robustness for rise time is 0.216 seconds. Settling time is 1.26 seconds. Overshoot is 25.5%. Peak is 0.929. Gain margin 21.5 dB. Phase margin 60.1 degree and closed loop stability is stable. Okay. So that's all for my part 3.1 and 3.2. Thank you.
Hi, my name is Zhang Xinling, matrix number CE190000F. For this lab 3 control, part number 3, I'm going to explain about 3.3 experiment using the PI controller. So this is the block diagram for the PID system that we used previously from the part 2. So now I will show the step how we tuning the system for the PI controller. First of all, we have to check the speed reference. So this is the parameter that we use, and then we go to the PID controller here. We double click, and then it will appear this, and then the proportional value I put it 0.1, and then the integral is 0.02. And then now we click the tune to see the output. So as you can see here, this is the output that we get after we click the auto tuning. This is the output, and then we can simply adjust the time here, the second, and then the transient behavior. We can adjust it. Let's say I adjust the time and second, then you will see the difference here. So this is the response, the transient response after tuning. And then we can also click the show parameters here. We can see the difference, the value. We can see the controller parameter after we click the show parameter icons here. You can see the block diagram, actual block diagram. I put 0.1 and then 0.02. Then here the tune here is after we tune the system, then the value is the P is 0.0107 and something. Then I become 0.0010 something. Then there is the difference here, and then the part below here is the performance and robustness. Then you can see the actual block rise time, settling time, overshoot, and then the auto tune system here. There is the different here. So for example, the rise time, the actual block before we tune the system is 0.057. Then after tune, the rise time becomes 0.41 second. Then the overshoot, and then the peak is having the slightly different there. And then now we go back to the simulating block diagram here. Click for the scope. Now we want to see the output here. Click run. So as you can see here, there is the difference. So as you can see here, this is the scope result for the PI controller after tuning system. After tune, this is the result. Then we can see the pre-shoot here is 0.543%, overshoot is 8.152%, and then the undershoot is 1.678, and then the time here, settling time, and so on. It's all here. So that's all from my part. Thank you.
Assalamualaikum and hi, my name is Ain Nadira bin Kamara Arifin and my number is CE100049. So for this part 3, lab 3 control the PID controller system. I will show the simulation for the question 3.4, which I need to repeat the block diagram from 3.1. But I need to get the auto tuning output and the output from this engine speed scope. So first, for the BEJ controller is TD. So set the block parameters. For the P is 0.1 and D is 0.02. Okay. Then we tune output, and this is the result. This is the result. There is the tune response, but no for the block response. For the parameter, when it is tuned, the P is equal negative 1.9779. I is not available. D is negative 0.20917. And A is 3048.5497. For the performance and robustness, when it is tuned, The rise time is 0.035 seconds. Settling time is 0.273 seconds. Overshoot is 12.1%. Peak is 1.07. Gain margin 11.9 dB. Alias 101 radius per second. For the phase margin is 59.9 degree, alias 26.7 radius per second. For the closed loop stability, it is stable state. So the closed loop system with controller gains defined in the PID block is unstable and not displayed, which is the block response is not displayed, as the PD controller is not commonly used because of the lack of integral term. Without the integral term, the error in steady state operation is minimized. Then PD controller is usually used in batch pH control loops, where steady state operation does not need to be minimized. So this is for the auto tuning response. And next is for the engine speed scope. So this is the output. There is a steady state. This is the steady state. We should over here. So for the rise time here, it is 923.702 millisecond. For the amplitude is 3.878. And for the overshoot is negative 0.218%. For the settling time is 642.894 millisecond. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakir bin Muhammad Hamzani. My matrix number is CE190085. So I will show you and explain about my part for question 3.5. So this is the plot diagram that I did for the 3.5. So it is the same as the previous one. So we have here the speed reference, error, PID controller, throttle and manifold, induction to power through delay, drag torque, combustion, vehicle dynamics. This is the rads to RPM, and then the engine speed RPM. So now I will show you on how I did the experiment. So you have to double click on the PID controller, so it will show you this one. So from PI I change it to the PID. So this is the value for P 0.1, I 0.02, and the derivative 0.03. So after that you need to click apply, and then you have to click tune. After you click tune, it will show you this. So this is the output that I got from the PID controller. So this is the output. This is the tune response. So it has only the tune response, because the block response has no, because there has no block response. As increasing, the proportional gain will speed up the control system response time, while lowering the steady state error. So which is the final difference between the process variable and the set point. However, if the proportional gain is too large, the process variable will begin to oscillate. So Next, I will show you the show parameters. So this is the controller parameters. For P, we have a negative 0.20836. For I, negative 0.48726. For D, negative 0.19799. For N, 480.33973. So this is the performance and robustness. So for the rise time, we have 0.36 seconds, settling time 1.404 seconds, overshoot 6.64%, for peak 1.007, gain margin 31.4 dB, phase margin 64.6 degree, and the closed loop stability is stable. So I think that's all from me. Thank you. Assalamualaikum. Hello, Assalamualaikum warahmatullahi wabarakatuh. So I will continue to explain for my part for part 3.6. So as you can see here, I got the table here for 3.6. So summarize all result in a suitable table. So this is the table. So we have a controller, a P, PI, PD, and PID, and then we have rise time, settle time, overshoot, and peak. So for P, the rise time is 0.216 second. For settle time, 1.6 second, 1.26 second. For overshoot, 25.5%, and the peak 0.929. For PI, for the second one, 0.0576 second, setting time 12.1 second, overshoot 88%, and the peak 1.88. So for the third one is the PD. The rise time is 0.035 second, setting time 0.273 second, overshoot 12.1%, and the peak is 1.07. So for the last one is PID. So the rise time for PID is 0.272 second. For the setting time 0.858 seconds. For overshoot 6.69%, and the peak 1.07. So I think that's all for the part 3.6 for the table. So that's all from me. Thank you. Assalamualaikum.